So this is Chapter 3, Section 1, Solving Linear Systems by Graphing. If you want, you can go to the PDF section and download the PDF of these notes to make sure that you can follow along as we fill these out. We're going to talk about solving linear systems by graphing and how that works versus what we've already done, solving linear systems by substitution or linear combination. I'm going to use my calculator to solve linear systems by graphing, and we're going to talk about what it means to solve a system. So the first way, the question is, what is a solution to a system? A system of equations, again, is two equations. 3x minus 2y equals 2, and x plus 2y equals 6. What I need to decide is 2, 2, and 0, negative 1. Are these solutions to both of these equations? So let's try 2, 2 first. So 3 times 2 minus 2 times 2. Is this equal to 2? I like to put a little question mark. So let's try that. 3 times 2 is 6. 2 times 2 is 4. 6 minus 4, is that equal to 2? Yes, it checks out. Let's try my second problem. My second problem says, plug in 2, 2 for x and y. Again, we have 2 plus 2 times 2. Is this equal to 6? Well, 2 times 2 is 4, so this is 2 plus 4. Yes, that is equal to 6. It checks out. That's my first solution. 2, 2 is the solution to my system because it is an answer for both equations. What about my other point? What about 0, 1? Let's try 0, negative 1. So 3 times 0 minus 2 times negative 1. Is this equal to 2? 3 times 0 is 0. Negative 2 times negative 1 is 2. So yes, 2 is equal to 2. That checks out. Let's try my other problem. Is it a solution for both? So the question is 0 plus 2 times negative 1. Is this equal to 6? Well, 0 plus 2 times negative 1, 2 times negative 1 is negative 2, so 0 plus negative 2 is negative 2. Is this equal to 6? No. So this is false. So this is not a solution to the entire system. Not just to the second equation, but to the entire system. For it to be a solution to the system, it has to work out for both the first equation and the second equation. Here it only worked out for the first equation. It didn't work out for the second equation, so it is not a solution. So let's go on to our next example. In our next example, we're going to actually solve this time, and we're going to solve by graphing. What I want to do then is graph both of these equations. I want to use my calculator, but to do this in my calculator, I first have to get it into y equals mx plus b slope-intercept form first. So what I have to do for letter A is I have to subtract 2x. So you get negative 3y is equal to negative 2x plus 1. Y is not by itself yet, so I'm going to go ahead and I am going to divide by negative 3 to every term. When I do that, I get y is equal to positive 2/3 x minus 1/3. It's solved for y, so I can pull up my calculator. I can go to y equals, and I can plug 2 divided by 3x minus 1 divided by 3. There's my first equation. Let's check my second equation. I have to solve this for y first. So the first thing I want to do is I'm going to subtract x from both sides. Y is equal to negative x plus 3. That's in slope-intercept form, y equals mx plus b. So I can plug that into my calculator. So I pull up my calculator. Y2, I'm going to say, is negative x plus 3. I'm now going to hit graph. and it's going to graph my two equations, and I can see that intersection point. That intersection point right there is my solution, and I'm going to let the calculator find that intersection point by hitting second, trace, which takes me to the calc menu. Number 5 is intersection point. First curve, hit enter. Second curve, hit enter. Guess, hit enter. And it gives me my intersection as the coordinate 2, 1. Yesterday we did elimination, we did substitution. Today we're using graphing, and it finds my solution just by plugging it into the calculator, making sure I plug it into the calculator correctly. Let's look at another example. Example B. Now, first of all, x equals 3, and then negative x plus y equals negative 1. I have this graph here because I'm going to talk about something in just a second. X equals 3, that's solved for x. It's not solved for y. I'm not sure how that's going to work. We'll get to that in a minute. But let's solve this one for y by adding x to both sides. I get y is equal to x minus 1. I can plug that into my calculator. So I go to my calculator, and I have two equations. I go to y equals, and my first equation was x is equal to 3. Notice I delete out those two other equations. I hit clear. X equals 3. There's no way to let the calculator say x equals 3. So what does this mean? X equals 3 tells me that I'm going to have a vertical line at x equals 3. And then my other equation is going to cross through, and I'm going to find that intersection point. Well, what does that mean exactly? Well, I can get this value without actually graphing the line x equals 3. I can go to the value and plug in x equals 3, and that's going to go ahead and give me that same thing as if I had graphed the line x equals 3. So in y1, I'm going to plug in my equation that I have, y equals x minus 1. I can't graph a line that says x equals, so instead I'm going to hit second trace to go to the calc button. I know what number 1, value, and it says x equals, so I'm going to plug in the 3 that I had for that, and it's going to tell me the value when x is 3 is 2, and that's the same thing as if the calculator was able to graph that line x equals 3. It can't, but I know that the intersection is 3, 2. By using value, again, how did I get there? I did second, I hit calc, which was the trace button, and then I clicked on value. And then I plugged in 3 for x equals 3. That's how I was able to graph this and find the answer using the calculator. So the next question we have are, how many solutions do I come up with? What do solutions look like? Well, first of all, when I graph my two equations, I'm going to have two lines. And if I have two different lines, wherever those two lines intersect, let's say they intersected there, that would be my solution. So whenever I have two distinct lines that cross, I end up with one solution to that system. What happens, however, if they end up with the same slope, and I end up with two parallel lines? Where do they intersect? Well, they don't intersect. So for this one, I have no solution, because the lines never intersect, so there's not a solution to both equations because they never sit on the same point at the same time. So if they have the same slope, the lines are parallel, then there's no solution. My third possibility looks like this. Now, realize I only drew one line. And I only drew one line because my two equations are the exact same equation, and they lie on top of each other. Since they lie on top of each other, they're the same equation. That tells me that I have infinitely many solutions. Every x I plug in is going to give me a y that is a solution to both equations, because both equations are an answer. I mean, both equations are the same equation. So that point is an answer to both equations. So that's what the graphs look like if I want to figure out how many solutions. One solution, they intersect at one point. No solutions, they're parallel. Infinite many solutions, I only see one line because they're on top of each other. Let's see what this looks like with problems. Example 3, tell how many solutions a linear system has. I'm not actually solving, I just want to tell how many they have. So if I was going to solve by graphing, I would go ahead and solve for y. So I would subtract 3x minus 3x. Negative 2y is equal to negative 3x plus 6. Then I'm going to go ahead and divide by that negative 2 to every term. And I get y is equal to 3 halves x plus, or should I say, minus, since that's a negative 2, minus 3. There's my first equation. Let's find my second equation. Over here, again, I want to get y by itself, so I'm going to subtract 6x. I get negative 4y is equal to negative 6x plus 12. I want to go ahead and divide by a negative 4 to every term. On the left side, I get y equals, this reduces to 3 halves x minus 3. I look at this and, hey, what do I notice? This equation here on the left and this equation here on the right are the same equation. So that tells me that there are infinitely many solutions, because they are the same line. Since they are the same line, there's infinitely many solutions. The lines lie on top of each other. Every x, y coordinate on that line is a solution, and there's infinitely many of them. Let's look at one other example. 3x minus 2y equals 6. 3x minus 2y equals 2. Again, I want to start this the same way. Solve for y. Minus 3x minus 3x. Negative 2y equals negative 3x plus 6. Divide by a negative 2. Divide by a negative 2. Divide by a negative 2. Y is equal to 3 halves x minus 3. Come to the right side. Subtract 3x, subtract 3x. Negative 2y is equal to negative 3x plus 2. Divide every term by a negative 2. And I get y is equal to 3 halves x minus 1. I need to be able to notice at this particular spot that 3 halves x and 3 halves x are identical. My slope is the same. And my y-intercepts, however, the negative 3 and the negative 1 are different. That tells me that there is no solution. These two lines have the same slope, but they go through a different y-intercept, so they are going to be parallel lines, and they will never, never, ever, ever cross. So there's no solution. So those are the end of our notes. Make sure that you've written these down, and we will go over them more in class tomorrow. Have a good evening.